This video is for the quadratic transformations. We're looking at reflections today. So what we're going to do first is we're going to reflect vertically. So we're going to reflect across the x-axis. And the rule for that is you're changing the sign of the entire function. You're multiplying a -1 by the entire function. So what this does, if you do this reflection, is it reverses the maximum or minimum of the parent function. So if you had a max to begin with, it's going to now be the minimum and vice versa. So a vertical reflection reflects the graph vertically over the horizontal axis, and this is the x-axis. All right, so our parent function in this one is the same one we've been using for the rest of these. It's this one here, and it's f of x equals x squared. So if I want to transform this, if I want to flip it over the x-axis, my new function, my transformation would be g of x equals negative x squared. And so what happens is you still square the x and then you change the sign of it. So the a here equals a -1. So anytime your a value is a negative, it's going to flip it and it's going to turn it upside down. Okay? So what this does is it reflects across the x-axis. All right, so write the reflected functions. F of x equals negative x squared minus 4x minus 2, reflection across the x-axis. So what we do, g of x, in this situation, is we're going to multiply the entire function by a -1, okay? So all that does is it just changes my signs. So negative x squared becomes positive x squared, negative 4x is positive 4x, and negative 2 becomes a positive 2. Okay? And that's the same no matter how we do it. And we can do it with it already in standard form. So that's the nice thing about it as well. So same with this next one here, g of x. I would multiply the entire function by a -1. So my new function would be negative 2x squared minus 12x minus 19. So vertical reflections are pretty easy to work with. All right, so now if we're going to reflect it across the y-axis, we're going to do a horizontal reflection. We are just multiplying the x value by a negative here. So this affects the vertex of the parent function. It reflects the graph horizontally over the vertical axis, or the y-axis. All right, so my parent function this time is a little bit different, because if I use the parent function, if I use this one of x squared, when I reflect it, it looks identical. It graphs on top of itself. Okay? So this time we're going to use f of x equals x minus 2 squared. Okay? So when we do our g of x here, all we're going to do is we're going to make this x negative. It's going to be negative x minus 2 squared. And again, to graph that, you can stick it in a table so you can see where it graphs. And so the b is what's changing here. Remember, the b value is the one right in front of the x inside the parentheses, is a -1. And so this reflects across the y-axis. So my original function, this is the parent function, and so you can see that it's perfectly mirror imaged and it's flipped across that y-axis. So to do these, you really need your function to be in vertex form. So I'm going to go ahead and just write this one in vertex form. This one is x minus 3 squared plus 4. So to do my transformation, g of x equals, again, all I do is I put a negative in front of that x. And then again, we do like things in standard form, so you can work this out, which would mean you're going to multiply negative x minus 3 times negative x minus 3. You're going to multiply that out there. So g of x is going to equal, all right, negative x times negative x is a positive x squared. Negative x times 3x is a positive 3x. Negative 3 times a negative x is a positive 3x. Negative 3 times negative 3 is a positive 9. And then we still have that plus 4 at the end. So now all we have to do is just combine our like terms. So 3x and 3x makes 6x. 9 and 4 makes 13. So by far way easier than our shifts and our stretches and compressions in some areas. So then this one, a reflection across the y-axis. So again, you do need it in vertex form. So you do need to be able to put a function in vertex form. So this one in vertex form is negative 3 x plus 1 squared minus 1. Okay, so g of x, we still have this negative 3 out front, but now I have a negative x inside those parentheses. Plus 1 squared minus 1. Okay, so I'm going to skip working this out like I did here and just write it. So g of x would be negative 3. If I square this, negative x plus 1, I get x squared minus 2x plus 1, and then we still have this minus 1. Now you can distribute. So you distribute this negative 3 across everything inside those parentheses. So we've got negative 3x squared, we've got a positive 6x, and we have a negative 3, and then still this minus 1 at the end. So our last step is going to be to combine like terms. Negative 3 minus 1 is a negative 4.